This is Unit 2, Day 2, first video. We're going to learn about the derivative of a function at a fixed point, the derivative at x equals a. So for example, the derivative at x equals 3 or the derivative of x equals 150. So first of all, this new word, derivative, really we've actually worked with it already in Day 1 of Unit 2. We talked on the last day about instantaneous rate of change of a function. We talked about the slope of a tangent line at a fixed point, the limit of the average rates of change, the slope of a secant line, and really what we were talking about was the derivative. That number we were finding, that instantaneous rate of change, is the derivative at that point. So we now need to start recognizing some synonyms and some notation for this value. So last time we were talking about the instantaneous rate of change of a function, for example, at t equals 3. We said that that's the same thing as the slope of a tangent line at t equals 3. But now we're going to begin calling that instantaneous rate of change the derivative of the function at t equals 3. The notation that we use, most of the time you're going to use the notation f prime of 3. So notice the difference between f of 3, which is a y value on the function f of t, whereas f prime of 3 is the derivative at t equals 3. It's the slope at t equals 3. So f of 3 versus f prime of 3. We want to know the difference there. An alternate notation, we won't use it as much, but we will use it now and then, is df dt at t equals 3. Now that might look confusing, but really it comes from this idea of change in y over change in x. Remember that a rate of change is a slope. It's a change in y over change in x. So they're saying if your function is f of x, it's kind of like, or f of t, change in f of t over change in t. And instead of the Greek symbol delta, they're just using df dt. But it means really the same thing. Then they have a vertical line to indicate we're finding this change in y over change in x at t equals 3, at this fixed x value. We also, of course, will work on interpreting the meaning of the derivative in context. We're going to continue to work on estimating derivative values on Excel, which we started in the last day of class. All right, so example 1, first just working with this notation and trying to make sense out of it. Suppose we have a function p of q. It's the company profit when producing and selling items. In this case, p of q is profit in thousands of dollars. And Q, the input, is number of items they sell. So this is just review. If they said P of 0 is negative 16.7, we know 0 is the number of items, and we know the negative 16.7 is the profit in thousands. So we can say when they produce and sell 0 items, their profit is negative $16.7 thousand, or in other words, negative $16,700. Part B is using this new notation, dp dq, dp dq. Again, this is the derivative p prime, and they're specifying dp dq when q is 450. So they're saying p prime of 450. The derivative when q is 450, the slope when q is 450. And they're saying the slope is 0.00725. The derivative is 0.00725. So this value over here, this 0.00725, is a rate. It's a slope of the function right at that moment in time. So if it helps, you could write that as a fraction, The units of the numerator are the change in y, the output. So this is the profit in thousands. And the denominator is the input, the change in the input. It's the items. It's saying if you go over one item, you go up $0.00725, thousands of dollars in profit. In other words, right at that moment when they're selling 450 items, if they sell one more item, profit will increase $0.00725 thousand dollars. In other words, $7.25. Another way to phrase that is sort of phrasing it in terms of rate. When selling 450 items, profits increasing at a rate of $7.25 per item. Either one of these phrasings would be accurate and appropriate. Notice, though, it is important to specify that this is happening when selling 450 items. It's possible, and probably likely actually, that their profit function is not a straight line linear function. It's possible that it's curvy, so that we need to specify that this rate of growth is only happening at 450 items. Okay, so part C, very similar, but just a different point on the function. Here they're saying the derivative of the function p when the input is q equals 972, so p prime of 972 is negative 0.00341. Negative rate, so the profit function is decreasing. The slope is negative. So again, this is thousands of dollars per item. So that really is going down $3.41 per item. And that's happening when producing and selling 972 items. Okay, part D gives us P of 620 is 958.642 and also gives us that P prime of 620 is 0. So P of 620 is talking about a y value on the function. P prime of 620 is talking about the rate, the slope at that time. So it's saying when they produce and sell 620 items, they have a profit of $958.642 thousand. So moving your decimal 3 places, that's $958,642. And at that instant, profit's neither increasing nor decreasing. It's flat for just an instant. It's constant for just an instant. And part E asks us to just sketch a possible graph of what the profit function could look like. Now, this is only a little bit of information we gained about this function, but I know Q is number of items produced and sold. And we were told P of Q is profit in thousands of dollars. And they've given us some information about some points on the graph and some rates of the graph at various instants. So first they said P of 0 is negative 16.7. So it's saying that's the y-intercept, 0 comma negative 16.7. When selling nothing, their profit is negative 16,700. Then it told us that if you go over to 450 items, the profit's increasing at a rate of 0.00725. So I'm just going to say over here is 475. They didn't tell me the height of the function at that time. They just told me that it was increasing. So I'm just going to say at that time let's say it's positive then. And whatever the height of the function is, the slope at this instant is 0.00725. Then in part C, they told us if you go over to 972, then the slope's negative. So at 972, the profit function's going down again. So again, let's just say that's over here, 972. So this maybe goes up, 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 and then maybe turns and starts to go down, down, down. And right here, I don't know how high the function is, but I know the slope was negative 0.00341. And lastly, part D, they did give us a point on the graph saying if you go over to 620, the height of the graph is 958.642, so that's, in between here somewhere. And it said that is where the function has a slope of 0 for an instant. So it's possible that the graph looks like this, that this is the highest point, this is the point, 620, and the y value is 958.642 here. And right at that instant, the slope of the tangent line is 0. So if you were to draw a tangent line, it would be horizontal and constant. Slope 0. So perhaps the profit function's increasing on the left. Right at that instant, it turns and begins to decrease on the right. This is just a possible graph. It's possible it has lots of other peaks and valleys and turns that they didn't describe in our problems here.